Hello, welcome to part 2 of lesson 5-6. Today we are going to continue simplifying radicals, but now we're going to be multiplying them. So just to forewarn you, there is a lot of factoring going on in all of these lessons. So if you need additional help in factoring, I would go back and look at lessons 5-5 parts 1 and 2. And possibly 3, but also you can email me to have a Zoom meeting too, and I can help you with it. All right, so we are going to solve problems by multiplying, and the rules definitely change when we're multiplying radicals. It does not matter if your radicand is the same or if it's different. So let's go ahead and get started on this first page. All right. So step 1, you're going to multiply all your coefficients together. Step 2, you are then going to multiply all of your radicands together, the numbers that are inside your radicals. Then you are going to simplify your radicals if you can, and then you're going to combine your simplified radicals. All right, so let's get started. When we're solving these, all we're doing is we're multiplying what's inside the radical. Now notice there is no symbol, there's not a parenthesis, a multiplication sign, a dot, anything like that. I put this on here because sometimes you might see problems that look like this, and if they're right next to each other like this with no symbol in between or operation in between, that just means you're going to multiply them. Okay, so I have the square root of 8 times 2, and that gives me the square root of 16, and then the square root of 16 is 4, and that is the first problem. Now, if you did not know that the square root of 16 was 4, you could factor it out, and you end up with 4 times 4, and that's how we got our answer of 4. Okay. All right, number 2, we are just going to multiply what is inside of the radical. So we're going to multiply our 2 radicands. 2 times 50, square root of 100, and the square root of 100 is 10. Okay. All right, now we have coefficients, and this doesn't change anything. We just multiply our coefficients together, and then we multiply our radicands together. So in this case, I'm going to have 6 times 4, square root of 2 times 3. So I'm multiplying my 2 coefficients together, 6 and 4, and then inside the square root symbol, I will be multiplying my 2 and my 3 together. I end up with 24 square root of 6. Now this step number 3 says that after we multiplied our coefficients and we multiplied our radicands, we then need to simplify if we can. Well, in this case, we can't, because when we factor out the 6, we get a 2 and a 3. There are no pairs there. So this is as far as we can go with this problem. All right. Same on practice 2. So I've done an example and a practice. I tried doing it this way to see how it goes. Here's an example, and now you can practice this on your own. Same concept though. Multiply your coefficients, multiply your radicands, and we end up with 15 square root of 14. Okay, example number 3, we have 6 squared root of 3 squared. All that means is we are going to take 6 square root of 3 times 6 square root of 3. Okay, so we multiply 6 times 6, and then 3 times 3 inside. Now I will, we'll do this problem and then I'll tell you what to expect in something like this. Okay, 6 times 6 is 36. 3 times 3 is 9. But the square root of 9 is 3. So we end up with 36 times 3, which gives you 108. Okay, now I've done every step, but anytime you multiply the same number by itself inside of a square root symbol, you really don't need to multiply it because you're going to end up getting 9 and the square root of 9 is 3. Basically, you can count these as pairs and pull them out and multiply them with the 6 times 6. And so that will eliminate one of your steps if you do it that way. All right, so let's look at practice 3. Okay, we have 4 times 4, square root of 6 times 6. Okay, and we know that these pair up, so we could take the 4 times 4 is 16, and 16 times 6 is 96. Okay. Now, if doing it this way makes more sense to you, do it this way. You would have ended up with 16 square root of 36 and then factored out your 2 6s and then multiplied 16 times that group of 6s. Okay. Example 4. Okay, so we don't want to forget that there is the A1 here. When you're multiplying though, it really doesn't matter because you're gonna, 2 times 1 is 2, right? So we're gonna take 2 times 1, square root of 6x times 4x. Now don't forget the rules of exponents. When you're multiplying exponents, you are adding their, when you're multiplying variables, you are adding their exponents. So each of these variables has an exponent of 1. Okay, so 2 times 1 is 2, and then you end up with 6 times 4 is 24, x times x is x squared, okay? And once you get to this point, you need to factor out your 24x squared, okay? So I am going to create a factor tree. Okay, we end up with 3 2s and a 3. And then don't forget your 2 x's. And I'm going to pair those up. Okay, so I can bring those 2 terms out and leave my 2 and 3 on the inside. And that is my answer. Okay, one other thing is if you're getting the hang of this, and this is pretty simple, notice how I multiplied these out. You could just factor out your 6 as 2 times 3 and your 4 is 2 times 2 and eliminate this step right here of factoring out your 24. But if that confuses you, go ahead and work out all of these steps here. And then practice problem number 4, I would try this one on your own. Okay, now that I factored it out, I'm going to match up my pairs here. And then I bring this out, 3 times 2 times x square root of, there's only 1 3 left over. And this gives us 6x square root of 3. Okay. All right, examples 5 and practice 5. Okay, so now we are dealing with distributing. Okay, so when you distribute, you're just taking your square root of 2 and you're multiplying it by 3. Okay, so 3 times your square root of 2. then in this case, you're adding, okay, your square root of 2 times square root of 6. Oops. Okay. So when you factor this out, you have 3 square root of 2 plus 2 square root of 6. And because we cannot go any further, they do not have like terms, and this is going back to our previous lesson, then we're done with this problem. And we're going to do the same thing here. You're going to do 8 square root of 3 plus the square root of 3 times 6. Oh, this time it's a little bit different. Okay, so you have 8 square root of 3 plus the square root of 18. So let's go ahead and factor out that 18 and see if we have like terms. Okay, so 8 square root of 3 plus 2 times 3 times 3. Okay, I can pull out my 3 here, and I end up with 8 square root of 3 plus 3 square root of 2. And that's as far as I can go with that problem. I can't combine them. Okay. All right, now we're moving on to page 2. Did everybody get that? Not everybody got that. Okay. And I have something highlighted at the top. So this is just continued from what we've been doing, how to multiply radicals. And I have this little tip up here. Sometimes it helps to simplify the radical before you multiply it, because you could end up with some very large numbers. Okay, and that is going to apply to the problems that from 8, 9, 9, and 10. Okay, so let's go ahead and continue with example and practice 6. Again, we're just distributing. Okay, so we're going to have the square root of 2 times the square root of 6, and then we're going to subtract. This time we're subtracting. So we did this. Now we're going to go and multiply the square root of 2 times the square root of 9. Okay, 2 times 6 minus 2 times 9 is the square root of 12 minus the square root of 18. Okay, so now I need to factor both of those out. So I end up with 2 times 2 times 3, and then 18. 2 times 3 times 3. Okay, so I'm going to find my common and pull those out. So now I have 2 square root of 3 minus 3 square root of 2. Okay, since our radicands are not the same, that is where our final answer is. So we cannot subtract those. They don't have like radicals. Okay, go ahead and try practice number 6. And you should have come up with this as your final answer. Okay. All right. Now we're going to start looking at the problems, some of the different types of problems. So we are going to go ahead and combine all of these together. So we have 24 times 2x times 3x. When we have something like this, we multiply all the coefficients together, and then we multiply our exponents together. So we basically have 24 times 2, which is 48, and then 48 times 3 is 144. So we have a square root of 144. And then we have two x's, so we add those exponents and we get x squared. So now I need to factor this, and I do know that 12 times 12 is 144, and then you have two x's. Those both pair up, so you end up with just 12x for that problem. Okay. All right. We are now going to do practice number 7. It's a little bit different. Notice that the square root of 5b is being squared. So you have 2b times the square root of 5b times the square root of 5b. Okay, because that one's being squared. Okay, so we're going to have 2b and then 5b times 5b. Notice that these already pair. We're going to be pulling a 5b out of it. I'm going to go ahead and keep doing it the long way, but if you can already see that we're pulling a 5b out and just going to multiply that by the 2b, you can do that. Okay, so I end up with 2b square root of 25b squared. Okay, so 25 times 5 is 25, and then we'll pull out two b's. So we have this paired up. So we end up with 2b times 5b, which gives us 10b squared. Okay, all right. Examples 8, example 8 and practice 8. Okay. So we're going back to just multiplying your coefficients and then multiplying your radicals. Now I had said sometimes it's easier to factor out what's inside the radical first and then do all your multiplying, and you can do that in this case. And so I'm going to show you how to do that. I'm going to factor out 21, and I get 3 times 7. So we have -5 square root 3 times 7. And then we're going to multiply that by -3. And then now I'm going to factor out the 42. Okay, so I have a 2, a 3, and a 7 that go in here. 2 times 3 times 7. So now I have both of these factored out, and watch what I do with these, okay? And then I'll explain. -5 times -3. So, oops, so I have to multiply my coefficients first. That's what I'm doing here. And then inside my radicals, I have a 2. I have 2 3s and 2 7s. So I already have them factored out here. Now, the other way that you could have done that is multiply 21 times 42 and then factored out that very large number. And so that is, that would be a little bit confusing, or not confusing, but it would just be a lot more work. And so just to give you an idea, 12 times 42 is 504. So you'd have a very, very long factor tree if you did it that way. So to me, it's easier to factor out first when you have problems like this, because now I can go ahead and pair up my numbers. Okay, and pull those out, and now I'm left with just a 2 on the inside. So -5 times -3 is 15, and then I pull out my 3 and my 7, square root of 2, okay? All right, so now we have 15 times 3, which is 45. And then 45 times 7 is 315. So 315 square root of 2 is your answer. Okay. All right, practice 8 is very similar to that if you want to try that. Okay, now I'm going to pull this all out. So -2 times -5, it's 10. And then I'm going to multiply that by 2 times 2 times 3. And then I'm left with the square root of 3 on the inside. Okay, so 10 times 2 is 20. 20 times 2 is 40. 40 times 3 is 120. So 120 square root of 3. All right. So we are moving to example and practice number 9. They're a little bit different from one another just because the example number 9 has a fraction, but you'll see that the fraction is going to cancel out and as you work this out. Okay, so we're going to factor out 18 and 8. So let's move here, 18 and then 8. This time I'm going to combine them. And then we have 14 C's. Well, all right, so we have -1/3 times a -6, and I'm going to put that over 1. Square root, I have, after I factored them out, I have 1, 2, 3, 4. 4 2s. And I have 2 3s. And then I have 14 C's. So let's see, 1, 2, 3, 4, 5, 6, 12, 13, 14. There we go. So we'll just bring this down. Now, some of you might already know, well, if you have 14 C's and you're pairing them into groups of 2, then you're going to have 7 C's left over. And that's true. That's what you would pull out. So all right, so here we go. -1/3 times -6 is, after I cross simplify, is 2. So all of our, we have 2 on the outside. All of our numbers, our radicand, they all pair up. So I'm going to end up with a whole number and no more radical. And there's 1, 2 2s, and then a 3, and then 7 C's. Okay, so 2 times 2 is 4, times 2 is 8, times 3 is 24. 24 C to the power of 7. Okay. All right, practice number 9. Okay, so 14 factors out to 2 and 7. So I have 2 times 3 because I'm multiplying both my coefficients. And then inside the radical, I have a 7, and a 2, okay? So 2 times 2 times 7, and then I have 3 T's, okay? I'm going to pair those up. And I end up with 2 times 3 is 6, times 2 times t that I pulled out, and 7 times t left over inside of my radical. 6 times 2 is 12, so I have 12t square root of 7t for this one. I did that wrong. I made a mistake. I'm going to go back. So let's redo this. So I put 2 2s, but I really have 2 7s. Okay. And so then I would need to fix this, and this, and this. There we go. 42t square root of 2t. Hopefully I don't have to write a disclaimer on this one. Okay, last problem. Chavez wants to find the area of a rectangular throw rug. So we have a rectangular throw rug, okay? The rug has a side length of 8 plus the square root of 5. Actually, I'll change this before I send it out to you, but it should just be 8 square root of 5. So I'll change that though. So it has a length of 8 square root of 5 and a width of 2 square root of 2. Okay. And so we know that the area of a rectangle is length times width. So we're just going to take these two and we're going to multiply them together. So 8 square root of 5 times 2 square root of 2. Okay. And we solve this like we did earlier. We have 8 times 2, and then the square root of 5 times 2, which gives us 16 square root of 10. And 10 cannot be factored out anymore, so that is our final answer. And we add on our units, and here we are. Okay. All right, so that is it for part 2. You will get part 3 next week. And if you have any questions, let me know. And I will see y'all next time.